Now the next program is whatever the earlier device, the same device you need to run the show. But if it is a PLC, if the hardware is modified, according to that program can also be modified. If you write a PLC program to operate 1 HP motor by pressing start and stop push buttons, incorporate a push button for jogging operation of motor. First program what we wrote, to turn on a lamp. Before staircase we wrote the same program we have to write to turn on a motor. Instead of lamp we have to turn on a motor. That's all. So we need a start button, start push button, that is required, that is X0 start. Then to stop we need another, normally open or normally closed. What I have to use, normally open or normally closed? To stop. How you are saying closed? Depends upon the hardware. Depends upon the, I'll tell. Depends upon the hardware. Suppose the hardware is always give one, means here what we have to put, normally open. Because it always gives one. We wrote the program like that earlier. Always it gives one. That's why we put normally open. Suppose we put normally open, another push button you are putting. That is normally open, means here what we have to put? Normally closed. We have to put normally closed. We understand that, we will write like that. We will put normally closed. If you put normally closed here, that name is X1. I am putting normally closed here. It means what? Both switch will be open initially. Both switch will be open initially. If you press X0, motor will be started. If you press X1, motor will be stopped. You understand that? You understand that? Okay. So both are giving 0. First one will be 0 only, and this will give 1 because both switches are open. That's why this gives 1, this gives 0. 0 and 1 equal to what? 0. That's why it will not turn on. I understand that. Why not? That's all. What happens to X0? Name, I gave the same name. That's the problem. Yes. Now we need a ceiling contact. So here in the second rung, we have put a normally open, but what should be the name? Why not? Because why not is the output. You have put here and put that's all. Now, if you press X0, motor will be turned on. If you press X1, motor will be turned off. You understand this? That's all. But we need a jogging operation also. So instead of why not, I can use memory variable. That is also possible. Because the PLC will be sold like that. 8 output, 16 output, 32 output, 64 output, like that it will be available. If you use more and more output modules, you cannot write more programs because you are using the output modules. Instead, you can use memory for some variables. For important outputs only, you are using the output module. I understand that. So instead of using Y naught, I can use M naught. M naught is only for memory. It is not available in the output module. I understand that. It is available only in the output image table, not in the output module. It is available in the output image table, not in the output module. So I can change the name, like instead of Y naught, I can change M naught. I can change M naught. So I changed M naught. It is not available in the output, but it is memory variable. That can be used because I have to do jog operation also. So here I am putting third rung is I am putting one more contact here. and its name is M0. Its name is M0. Here also ceiling contact also what? It should be M0. Double click and change the name to M0 because we changed the output name. So it also must be M0. So M0 is available. If you connect the device Y0 in the output, if you connect Y0, Y0 is connected in the output. Yes. Now motor will be connected at Y0, not M0. M0 is only memory variable. That memory will be placed here. That memory will turn on the motor. Now I need a jog operation, or the motor should run for jog operation or switching operation. So I am putting R. That's why I am putting in parallel. So one more jog operation. That is X1. Another input, that is X1. It is for jogging. Jogging. That's all. Once I press the X0, motor will continuously run. Motor will continuously run. Programming is over. Now let us compile this program. Compile this program. Is compiled. It is saved. First we have to save, then compile. Compiled. Now let us simulate. Now simulator is turned on. Online mode is required. If you put this online mode, if you run the program connected with PLC, whatever the data available here, it will reflect. Suppose the motor is on, means this Y0 will be 1. Green. For that online is required. It will interface automatically. Okay. So now it is in stop mode. The program is in stop mode. I want to run that program. So here I have to run. It is in run mode. I want to turn on the motor. Motor is connected where? Y0. Motor is connected to Y0. M0 is memory variable. M0 is memory variable. So I have to turn on that X0. It is push button, but I am having toggle switch. That's why I have to turn on and off. Set on, set off. But motor is still on. That's all. The motor remains off. I want a jog. Jog means which I have to use. So it should be X2, you know. Should be X2. I use the same name. All are sleeping. Okay. It should be X2. Yes. Save. Compile. Compiled. Then simulator. Then online mode. Then run mode. This is in run. So we are turning on the motor by setting X0 on, then immediately off, but motor is running. Suppose you want to turn off the motor, you press X1 once, set on and off. Motor is turned off. If you want to jog, you have to use X2. Set on jogging. For some time, then I turned off. X2 is used for jogging. X1 is to stop. X0 is to start. You understand this? That's all. In the connection diagram, this is input module. You have to draw in the examination. So 5 volt will be available. Plus 5 volt is available. That you can take. The switches are available. This is X0. This is connected to This is connected to X0. Another switch is available. That is also normally open. This is normally open. This is also normally open. This is connected to X1. This is connected to 5 volt. This is also connected to 5 volt. This is the connection diagram. X0, X1, then X2 is there for jogging purpose. X2 is there. That is also another push button normally open. That is connected to X2. This is also connected to 5 volt. This is also connected to 5 volt. That's all. This is the connection diagram in the input module. But already it is available in the lab. That's why no need to do. Then in the output module, what you have to do? In the output module, no M0 is available. Y0, Y1, Y2, Y3 is available. Neutral is available. Neutral is available. 230 volt is available. It is a 230 volt output module. They will sell like this. 12 volt output module. They will sell like that. 5 volt output module like that they will sell. 230 volt output module like that they will tell. 440 volt output module. Current also they will mention. I'm not mentioning here. They will tell like that, the output module. Here, let us assume that it is a 230 volt output module. In that Y0, I am connecting the motor. I am connecting the motor in the Y0. That's all. It's working fine. This is PLC. This is PLC. The output you can see only input module and output module. And the communication cable will be there. Communication cable, power supply will be there. Communication cable to PC is power supply to power supply. Power supply cable. That's all. And here indicators will be there. Y0 is on means this will the LED will glow. If it is on means similarly if X0 is on means here LED will be there. X1 on LED will be there. Here on LED will be there. It will glow. If it is 1 means, logic 1 means. Logic 0 means it won't glow. From that, which one is on and off, you can understand.